A world that should have been dead is breathing. 9.5 years ago, a small spacecraft flew past a tiny frozen ball at the edge of our solar system, and what it saw broke almost every prediction scientists had written down. Nobody expected ice mountains. Nobody expected fresh, smooth plains with no craters at all, on a planet that is colder than any freezer you have ever opened. Stick around, because this story is not just about a distant rock in the dark. Subscribe now if you want more of these deep space mysteries showing up in your feed, because this channel digs into the strange stuff other channels skip past. Picture standing in your kitchen at night, opening the freezer, and feeling that blast of cold air on your face. Now imagine a place 230 degrees colder than that freezer, sitting 3 billion miles from the sun. That is where our story happens today. And somehow, against every expectation, that frozen place still seems to be moving, changing, and maybe even alive in a way nobody predicted. The place is Pluto. For most of your life, you probably heard one simple sentence about it. Pluto is a dwarf planet, and dwarf planets are boring, leftover rocks. That sentence is not exactly a lie, but it hides something important, and by the end of this video, you will understand why that sentence undersells one of the strangest worlds we have ever seen up close. Let us go back to where this story actually begins, because the beginning explains everything that comes after. Here is the misconception we need to clear up first. Most people believe Pluto has always been considered a minor, uninteresting object, barely worth studying, a frozen leftover with nothing going on. That belief is wrong, and it is wrong because of what scientists actually found when they finally got a close look. When Pluto was first spotted in 1930 by a young astronomer named Tombaugh, working at the Lowell Observatory in Arizona, it was treated as a full planet, the 9th one from the Sun. For decades, it held that title with pride. Then, in 2006, an organization called the International Astronomical Union reclassified it as a dwarf planet, and almost overnight, the public imagination downgraded Pluto from a planet to an afterthought. Textbooks changed. Jokes were made. Pluto became the punchline of the solar system. Here is our underdog, a tiny, distant world, demoted, mocked, and largely ignored by the public for years, sitting so far from the sun that sunlight takes over 5 hours to reach it. Compare that to the 8 minutes it takes sunlight to reach your bathroom mirror here on Earth. Pluto was treated like a nobody. And nobodies, as it turns out, sometimes hold the biggest surprises. In that same year Pluto was demoted, 2006, something else happened that nobody connected at the time. NASA launched a spacecraft called New Horizons on January 19th, heading straight for this newly demoted, supposedly boring little world. The spacecraft was about the size of a grand piano, and it carried 7 scientific instruments built to answer one simple question. What does Pluto actually look like up close, and what is really happening on its surface? It took New Horizons 9.5 years to get there. Think about that. A child born the day it launched would have been starting 4th grade by the time it arrived. The spacecraft covered more than 3 billion miles, traveling at roughly 30,800 miles per hour, which is fast enough to cross the entire distance between New York and Los Angeles in under 5 minutes. And on July 14, 2015, at 7:49 in the morning Eastern Time, New Horizons reached its closest point to Pluto, just 7,750 miles above the surface. Scientists expected a dead world. Most researchers, including many working at NASA and the Johns Hopkins Applied Physics Laboratory, which built and operated the spacecraft, predicted a heavily cratered, ancient, unchanging surface, similar to our own moon. A frozen ball that had not changed in billions of years, just sitting there collecting impact scars like a punching bag that never gets replaced. What they actually found stopped mission scientists in their tracks. Alan Stern, the lead scientist on the New Horizons mission, based at the Southwest Research Institute, has described the moment the first close images came back as one of the most surprising in his entire career. Instead of an old, battered, cratered face, Pluto showed huge stretches of smooth ice with almost no craters at all, meaning something had resurfaced them recently, geologically speaking. Compress that surprise for a second. Imagine finding a 100-year-old wooden porch, expecting it to be splintered, cracked, and gray, and instead finding a patch of it looks freshly painted, like it was redone last week. That is the kind of contradiction scientists were staring at. A world billions of years old, with patches that looked almost brand new. The first surprise scientists confirmed was a massive, bright, heart-shaped region on Pluto's surface, nicknamed Tombaugh Regio, after the astronomer who discovered the planet. Inside that heart shape sits an area called Sputnik Planitia, a plain roughly the size of Texas, made of frozen nitrogen ice. And this plain has almost no craters on it, which told scientists the surface there is younger than 1 million years old. On a body 4.5 billion years old, 1 million years is basically yesterday. Here is where the domestic comparison helps again. If Pluto's whole history were squeezed into one 24-hour day, that fresh nitrogen ice plain would have formed in the last quarter of a second before midnight. Something is actively resurfacing parts of this supposedly dead, frozen world, and scientists needed to figure out what. The second finding changed everything scientists thought they understood about small, icy worlds. Data sent back from New Horizons showed that the nitrogen ice in Sputnik Planitia is not just sitting still. It is slowly churning, like a lava lamp, in giant cells tens of miles across, rising, cooling, sinking, and rising again, over and over, in cycles that may take hundreds of thousands of years to complete one loop. Scientists expected frozen nitrogen to behave like the ice cubes in your freezer, hard, brittle, and completely still. What they found instead was nitrogen ice behaving almost like a thick, slow-moving liquid, folding and turning over from heat rising up from somewhere underneath the surface. Compress that surprise into something familiar. Picture a pot of thick oatmeal on the stove, slowly bubbling and folding over itself. That is roughly what is happening to solid ice, on a world where the surface temperature sits around negative 387 degrees Fahrenheit. Would you comment below and tell me which discovery on this list surprises you the most so far? I read through the comments myself, and they genuinely helped me figure out which mysteries you want covered next on this channel. Let us keep going, because the third discovery puzzled scientists the most, and it is the one that eventually led to today's bigger mystery. Underneath that churning nitrogen ice, researchers began finding signs that Pluto might be hiding something enormous, something nobody expected from a small, frozen, distant world with no sunlight to speak of. To understand why this mattered, we need to jump back out to cosmic scale for a moment. Pluto orbits the Sun once every 248 Earth years, moving through a region called the Kuiper Belt, a ring of icy debris far beyond Neptune. Out there, sunlight is so weak that even at high noon on Pluto, the sky would look like a deep, dim twilight here on Earth, more like an hour after sunset than a bright afternoon. With sunlight that weak, scientists assumed Pluto's interior would have gone cold and solid billions of years ago, frozen straight through, like a stone. But measurements of Sputnik Planitia's shape and position told a different story. The basin sits directly opposite Pluto's largest moon, Charon, in a very specific alignment, and researchers realized that alignment only makes sense if there is a layer of liquid water sloshing beneath the ice, tens of miles down. Picture the water in your bathtub. Now imagine an ocean, buried under a shell of ice up to 60 miles thick, kept from freezing solid by heat left over from Pluto's formation, and possibly by radioactive material slowly decaying deep inside the core, warming things from within. The same basic process that keeps a portion of Earth's interior warm today. A subsurface ocean on a world this small, this cold, and this far from the Sun was not something most scientists had predicted before New Horizons arrived. This is our second surprise reveal, following the same three-beat pattern as before. Expected, a solid, frozen interior all the way through. Found, possible liquid water hidden under the ice. Compressed, it is a bit like discovering a working, unfrozen pond underneath a hockey rink that has supposedly been frozen solid for a century. Let us shift scale again, back down to something small and familiar. Pluto's entire atmosphere, thin and hazy, made mostly of nitrogen with traces of methane and carbon monoxide, exerts a surface pressure about 100,000 times weaker than the air pressure inside your kitchen right now. If you could stand on Pluto without a spacesuit, the air pressure would be so low your blood would essentially boil away almost instantly, even in temperatures that cold. It is a world of extremes stacked directly against each other. And yet, New Horizons found layer upon layer of blue-tinted haze stretching more than 100 miles above Pluto's surface, backlit by the sun into thin, glowing bands, like layers of smoke caught in a flashlight beam in a dark room. Nobody expected a small world with such thin air to have a rich, layered, structured atmosphere like that. Researchers counted more than a dozen distinct haze layers in the earliest images, each one photographed with remarkable precision. Here is a piece of authority worth noting directly. The imagery and atmospheric data were published in a paper in the journal Science on October 15, 2015, led by members of the New Horizons science team, with contributions from researchers connected to NASA's Goddard Space Flight Center. That paper confirmed something researchers had only guessed at before the flyby, that Pluto's atmosphere behaves in complex, layered ways nobody had modeled correctly using ground-based telescopes alone. Would you take a second to like this video and let the channel know these deep-dive science breakdowns are worth making more of? It genuinely helps signal to YouTube that stories like this deserve to reach more curious minds like you. Let us get even more precise for a moment, because the exact instruments used matter here. New Horizons carried a camera called LORRI, short for Long Range Reconnaissance Imager, capable of spotting details as small as about 230 feet across from thousands of miles away, roughly sharp enough to make out a single football field from the distance between two neighboring cities. It also carried an instrument called ALICE, which studied the composition of Pluto's thin atmosphere, and another called RALPH, which mapped surface colors and temperatures across the entire encounter. Using data from these instruments, scientists measured Pluto's surface temperature with startling precision, recording an average of about -387 degrees Fahrenheit, with some shaded regions dropping even colder, down toward -400 degrees. For comparison, the coldest temperature ever recorded naturally on Earth, in Antarctica, was about -136 degrees Fahrenheit. Pluto, on an average day, is roughly 2.5 times colder than the coldest place humans have ever measured on our own planet. Let us talk about sound and feeling for a moment, because numbers alone do not capture what standing on Pluto would actually be like. Imagine the silence first. With almost no atmosphere to carry sound waves, Pluto would be nearly silent, the kind of silence that presses against your ears, broken only by the occasional groan of ice shifting somewhere beneath your boots. Above you, a dim, reddish haze would hang in a sky lit faintly by a sun that looks like nothing more than an unusually bright star. Now picture the texture under your boots on that frozen plain of Sputnik Planitia. Not hard and jagged like typical rock, but strangely smooth, faintly ridged in giant polygon shapes tens of miles wide, like the surface of a dried lakebed back on Earth, except stretched out to the size of small countries, and made entirely of frozen nitrogen instead of dried mud. That combination, silence above, slow motion churning below, is part of why New Horizons scientists describe Pluto not as a dead rock, but as what they now call a geologically active world. Active does not mean volcanoes erupting constantly. It means the surface is still changing, still being reshaped by forces working from the inside out, something almost nobody predicted for a body this small, this cold, and this far from any real source of heat. This next part is where the story gets genuinely uncertain, and honestly, that uncertainty is part of what makes it exciting. Scientists will tell you they do not fully understand exactly how Pluto has stayed warm enough, for long enough, to keep an ocean liquid under all that ice. The math is difficult. Small worlds are supposed to lose their internal heat quickly, over just a few 100 million years, yet Pluto appears to have kept some of its heat for over 4 billion years. Some researchers argue that a thick layer of gas hydrates, an icy substance that traps and holds heat like an insulating blanket, sits between the ocean and the outer ice shell, slowing the escape of warmth from deep inside. Others argue the amount of radioactive material inside Pluto's rocky core may have been underestimated. This is still debated within the planetary science community, and new papers on the subject continue to be published, including work discussed in the journal Nature Astronomy, examining Pluto's thermal history in detail. That uncertainty is not a failure of science. It is the honest, unfinished edge of discovery, the exact spot where the next generation of researchers, maybe some of you watching this, will need to pick up the thread and keep pulling. There is something else worth mentioning before we move on, something that surprised even the engineers who built the spacecraft. New Horizons was designed years before launch, using the best telescope images available at the time, which showed Pluto only as a fuzzy blur of a few pixels, not much clearer than a smudge on a foggy window. Every single detail we have talked about today, the mountains, the plains, the haze layers, the possible ocean, was completely invisible until the spacecraft got within striking distance in the final days before closest approach. That means for nearly the entire 9.5-year journey, scientists were essentially flying toward a blank, unknown face, hoping their instruments would work correctly the very first time, with no chance for a do-over. There was no second flyby planned, no return trip scheduled. One shot, 3 billion miles, and roughly 9.5 years to get it exactly right. When the data finally started coming back that July, it did not just answer questions. It revealed there had been far bigger questions waiting all along than anyone thought to ask. Let us pull back to cosmic scale one final time before we return home. Pluto is so far from the Sun that its 248-year orbit means it has not even completed one full trip around the Sun since it was discovered by Clyde Tombaugh back in 1930. We are less than a century into watching a fraction of a single Pluto year unfold, and we already know it is doing things nobody thought possible for a world this size. Compare that cosmic patience to something small and immediate. The next time you check the calendar on your kitchen wall and flip the page from one month to the next, remember that Pluto is still working through the very same orbit it was on the day it was discovered, moving so slowly through space that entire human lifetimes pass like brief flickers against its enormous, unhurried year. Would you consider sharing this video with someone who still thinks Pluto is just a boring, frozen rock at the edge of the solar system? Sharing helps this story reach people who genuinely have not heard how strange and active this little world actually turned out to be. There is one more layer to this mystery worth walking through, because it connects everything we have covered so far. If Pluto really does have a liquid ocean hidden under its icy shell, and if that ocean has stayed liquid for billions of years, then researchers have to ask an uncomfortable question. Could conditions down there, in total darkness, under crushing pressure, ever have supported the basic chemistry associated with life, the way scientists suspect might be possible in the hidden oceans of Europa or Enceladus, two icy moons orbiting Jupiter and Saturn? Nobody is claiming Pluto has life. That would be getting far ahead of the evidence we actually have. But the fact that the question is even being asked seriously, about a world that was treated as a lifeless leftover just 20 years ago, shows how completely our picture of Pluto has been rebuilt from the ground up. The underdog kept surprising everyone, piece by piece, discovery by discovery. Researchers connected to NASA's Jet Propulsion Laboratory, working alongside the original New Horizons team, continue to model Pluto's interior using the flyby data, trying to narrow down exactly how thick that ocean layer might be and how close it might sit to the icy surface in certain regions. Some estimates place the ocean as close as 10 to 20 miles beneath Sputnik Planitia, separated from the vacuum of space by a shell of ice roughly as thick as the distance between two mid-sized cities placed end to end. Every one of these numbers, the thickness of the ice, the depth of the ocean, the timing of the resurfacing, keeps getting refined as scientists reprocess the flyby data using better tools years after New Horizons actually passed by. The spacecraft itself did not stop after Pluto. It kept flying outward, and in 2019, it flew past an even more distant object called Arrokoth, roughly 1 billion miles beyond Pluto, giving scientists their first ever close look at a truly primitive building block left over from the earliest days of our solar system. But Pluto remains the centerpiece of the story, the place where expectations were flipped upside down in a single flyby that lasted only a matter of hours. 9.5 years of travel, 3 billion miles crossed, and all of it aimed at a world the world itself had decided was not worth calling a planet anymore. Would you drop a comment letting me know if you think Pluto deserves to be called a planet again, now that we know how active it actually is? I read every comment personally, and honestly, this question splits people right down the middle every single time I ask it. Here is something worth sitting with as we head toward the end of this story. The heart-shaped region on Pluto, Tombaugh Regio, sits roughly centered on the side of the planet that permanently faces its largest moon, Charon, locked in a slow gravitational dance the same way our own moon always shows Earth the same face. Two frozen worlds, holding each other in place across 13,000 miles of empty space, spinning together for billions of years, largely unnoticed by almost everyone until 9 years ago. That image, two small, cold, distant worlds locked together in a silent gravitational embrace, is oddly beautiful once you actually picture it. It is easy to imagine Pluto as nothing but a lonely, frozen speck, but it has never really been alone out there. It has had a partner this entire time, and together, the two of them have been quietly rewriting what small worlds at the edge of the solar system are capable of doing. Let us look a little closer at the mountains, because this part still confuses scientists in a very specific way. Along the edge of Sputnik Planitia sit ranges of ice mountains, some rising more than 11,000 feet high, roughly the height of some peaks in the Rocky Mountains back here on Earth. Except these mountains are not made of rock the way ours are. Researchers believe they are made largely of water ice, frozen so hard at Pluto's temperatures that it behaves almost like solid granite instead of the soft, crumbly ice you might picture from your freezer. Scientists expected small, icy moons and dwarf planets to have gentle, worn-down terrain, smoothed flat over billions of years with nothing left to build mountains at all. What they found instead were sharp, jagged peaks, looking almost freshly carved, jutting up along the edge of that giant frozen plain like teeth along a jaw. Compress that surprise into something familiar. Picture finding fresh, jagged mountains poking up out of what should have been a flat, worn-out parking lot that has not been touched in 100 years. There is a specific piece of authority worth mentioning here, spaced apart from the others so it does not feel repetitive. Researchers from NASA's New Horizons team, working with colleagues at the Southwest Research Institute, published detailed mapping of these ice mountains in the months following the flyby, cataloging peaks and naming several of them after early pioneers of polar and space exploration. Some of that naming work continues even now, years after the spacecraft first sent its pictures home. Let us drop back down to something small for a moment. Imagine the coldest your hands have ever felt, maybe grabbing a bag of ice straight out of the freezer without a towel. Multiply that discomfort by roughly 300, and you get close to the temperature of Pluto's surface ice. And yet, underneath all of that brutal cold, heat is still quietly rising up from somewhere deep inside, patient and steady, like a low flame that has never quite gone out. That rising heat is probably the same reason we see reddish-brown patches scattered across parts of Pluto's surface, a coloring scientists call tholins. These reddish compounds form when sunlight and cosmic rays strike the simple gases in Pluto's thin atmosphere, breaking them apart and rebuilding them into more complex organic molecules that slowly drift down and coat the surface like a light dusting of rust-colored snow. It is a strange kind of chemistry happening quietly, far from any warmth, over millions of years. None of this fits the old picture of Pluto as a plain, gray, forgotten snowball. Instead, mission scientists describe a world with reddish highlands, bright frozen plains, towering ice mountains, layered blue hazes, and possibly a hidden ocean, all packed onto a body smaller than Earth's own moon. It is a small world, doing an enormous amount of work to surprise everyone who ever doubted it mattered. Let us talk for a moment about how Pluto ended up out there in the first place, because the story of its birth is just as strange as the story of its surface. Around 4.5 billion years ago, in the swirling disk of gas and dust that eventually formed our entire solar system, small icy bodies out past Neptune began sticking together, clumping bit by bit, the same slow process that built every planet, moon, and asteroid we know about today. Pluto was one of thousands of these icy leftovers, never growing large enough to clear its orbital neighborhood the way Earth or Jupiter did, which is part of the technical reason it eventually lost its full planet status. But size alone never tells the whole story. Pluto is not traveling alone out there. It has 5 known moons, and the largest, Charon, is so big compared to Pluto, about half its diameter, that many scientists describe the two as a double system, rather than a simple planet and moon pair, both worlds locked in a slow, permanent gravitational handshake, spinning around a shared point in space that sits just outside Pluto's own surface. Picture 2 ice skaters holding hands, spinning together on a rink, neither one ever quite letting go, both moving around a fixed point between them rather than one circling the other. That is roughly the dance Pluto and Charon have been performing for over 4 billion years, largely unnoticed by anyone until a camera finally got close enough to see it clearly. The New Horizons team also caught remarkable detail on Charon itself during that same 2015 flyby, including a massive, dark reddish spot near its north pole, nicknamed Mordor Macula, and a giant canyon system stretching over 1,000 miles, roughly 4 times longer than the Grand Canyon here on Earth. Nobody expected Pluto's quiet, icy companion to have its own set of dramatic, unexplained features either, sitting right there the entire time, waiting patiently for a spacecraft to finally notice. Would you tap like on this video if learning about Charon just now genuinely surprised you? That kind of quick signal tells YouTube this story is landing with the right audience, so more people get the chance to see it. Every piece of this story, the mountains, the ocean, the moons, the haze, keeps pointing toward the same larger lesson. Distance and darkness do not automatically mean a place is dead or finished changing. Pluto sits so far from the Sun that its entire 24-hour day only receives about 1/900th the sunlight Earth receives at noon, roughly the amount of light you would get from a single bathroom nightlight glowing in an otherwise pitch-dark room. And even under that faint, thin light, something down there is still active, still moving, still building mountains and churning ice after 4.5 billion years. So here is where we land. A tiny, demoted, mocked little world turned out to be hiding fresh ice plains, churning nitrogen, layered blue hazes, jagged ice mountains, a hidden ocean, and a companion moon with mysteries of its own, all wrapped inside a shell of ice colder than almost anywhere else humans have ever measured. Nobody expected any of it, and the questions it raised are still not fully answered. Think back to the very first thing I told you, that a world that should have been dead is breathing. That sentence sounded strange at the start of this video, maybe even a little too poetic to be real science, but now you know exactly what it means. You know about the churning nitrogen plains, rising and folding like slow breath beneath a frozen chest. You know about the heat quietly leaking up from somewhere deep inside, keeping an ocean liquid under 60 miles of ice that should, by every old assumption, have been solid billions of years ago. At the start, I told you nobody expected ice mountains or fresh, crater-free plains on a supposedly dead world. Now you understand exactly why that was such a shock, and you understand the mechanism scientists suspect is behind it. Heat rising from within, patient and unseen, reshaping the surface in slow motion across timescales longer than human history itself. What once sounded like an impossible contradiction now sounds, hopefully, like something you could explain to a friend over dinner tonight. Here is the last image I want to leave you with. Somewhere out past Neptune right now, in silence, in cold darker than any freezer, under a sky lit by a sun that looks like nothing more than a bright star, ice is still slowly turning over, mountains are still standing sharp and new, and an ocean that should not exist is still, somehow, quietly liquid. Few people ever think about Pluto at all anymore, but maybe now you will be one of the ones who does. The next time someone tells you Pluto is just a boring, frozen, forgotten leftover, you will know better. You will know that a world 9.5 years and 3 billion miles away is still, right now, breathing.